Okay, now let's do an example. The question is, find the integral of x times cosine of x. And you can recognize it straight away as an integration by parts question, because s and the cosine of x are very different functions. They are by no means related by derivatives. You can't differentiate one to get the other. So it will be very straightforward. And first, we need to choose u and dv. For this question, I will choose x as u. So we write u equals to x, and then dv is cosine of x dx. Why? Because if u just equals x, then du is just dx. It's very simple. So you will just basically get rid of x. And for the other part, dv is cosine x dx, and v is just the integral of this thing. And the integral of cosine of x is sine of x. You don't need to plus c here now. If you don't remember what the integral of cosine of x is, you should remember it as sine of x. Although you can write it in your cheat sheet, but it will be better if you can remember them. And now the question is very clear. You just use the formula. If you remember, it says u dv equals uv. So you write these two. uv is x sine x, and the minus integral of v du. So v is this one, sine of x, and du is just dx. And now the integral is very straightforward. The first part is already done. You don't need to change it. And if you can remember, the integral of sine of x is negative of cosine of x. So the negative will cancel out with this negative, leaving with a positive. So plus cosine of x. And don't forget to plus c at the end. So you are basically done with your problem now. You can go back to check it, differentiate this one to ensure you get the original expression. And following from our last examples, we'll do another slightly trickier one. It says, show that the integral of e to the power of ax times sine of bx dx is equal to this thing, and where a and b are just constants. So this is a show that question. You need to be very mindful of your steps. So as you may use the isolate rule, this t and the e are both here, so it doesn't matter which one to choose for u and which one for v. And for this case, I will just choose this as u and this as dv. So we say u is e to the power of ax, and dv is sine bx dx. And then you just need to differentiate du, or you can be like, I will write them in one more step here, du dx. And now you need to differentiate this thing, and you remember the derivative of e to the power of x or e to the power of anything is just itself, e to the power of ax. But then you need to use the chain rule. You need to times it by the derivative of this thing. So derivative of ax is just a times a. So it means du, just move this dx to the right hand side, and I will move a to the front as well. A e ax dx. And for the dv, if you want to work out the v, just integrate both sides. So I'll write it out more explicitly. V is just integral of dv. So integral and differential just basically cancel, and you integrate this side. Integral of sine, we just did it here, is negative of cosine. So it's negative of cosine bx. But now you also need to use the reverse of the chain rule, so we need to divide by the derivative of the inside part. This only works for the linear function in the inside. So derivative of bx is just 1 over b. So I will put 1 over b in the front. And now you have your u, dv, du, and v. You can just use the integral formula, integration by parts. And now for this integral, if I just let it equals to I, because I don't want to write this whole expression again, we just say I is equal to, and if you remember your formula is, this is u dv equals uv, u is this one, e to the ax, uv, and v is this thing, is 1 minus 1 over b cosine bx, and then minus v du integral, and the v is here. I will pull this factor out in front, and the minus 1 with this minus makes a plus, and 1 over b here, and we still got a cosine of bx here, and du is this thing. For this thing, because a is a constant, it doesn't affect integration, I will also put it out. So we will say a is this thing here, and rest of is a to the power of e to the power of ax dx. So got this thing here, and you can recognize you need to use the integration by parts again in this case, because you can see these two things are very the same, just this one is sine of bx and this one is the cosine of bx. And from what I talk about, you need to be consistent in these questions. You let u use e to the power of ax in the first case, and now in the second time you also need to do the same thing. You need to let still u equals e to the power of ax and dv, but now dv is this thing, because the integral are changed slightly, because of cosine of bx, and then dx. And then just do the same thing. Du is basically the same as this one. I'll write it again for you. Du is a e power of ax dx, and v, and just integrate this thing, and the integral of cosine is sine, so it's sine bx. But now still you need to use the inverse of the chain rule. You need to divide it by the b here, the derivative of the inside. And now for this part, you just need to use the integration by parts again. And now I is equal to, the first part doesn't change, but I will write this minus 1 over b in the front, minus 1 over b to the power of ax cosine of bx, plus a over b, this thing is the factor here, just don't forget it. And now we will use a bracket, and using the formula is uv, this thing uv, 1 over b, I will put it out in the front, 1 over b to the power of ax and the sine bx, and minus integral of v du. So this thing v, I will again pull out this 1 over b factor here, and the sine bx, and du. Du is here. I will again pull out the a here, place that there, and then for the rest of the thing I just put it in the power of ax dx. And now if you are careful with your observation, you find this thing is exactly our integral I. So it's integral of e to the power of ax times sine of bx. These two things are exactly the same, they're just different in different orders. So you can write it out as, the first part won't change, I will just copy it down. Yeah, for these questions, the first part you need to constantly copy it down. It's annoying, but you need to do it. And this thing is just our original integral I. And now you can expand the bracket now. I will expand it. Plus this one, 2b's in the denominator, you make b squared. And minus a times a, b over b times b. A squared is a squared over b squared. I. Or you don't need the bracket here, sorry. And now you can just move the I over here. There's an I in this step. I just didn't write it. You can just move it here. it will be I, and if you move it to the other side, it will be a plus a squared b squared I. And then you can just take out the common factor of I here, which is the thing you're after. If you take out common factor, this one is 1I, so it's 1 plus a squared over b squared I. And is equal to this whole thing here. I'll write it out for you. And for now, you can also take out a common factor here. You can take out common factor of e to the power of ax here. I'll just take it out. And maybe I will write the sign in the front. As you can observe from the question, the sign is in the front. And you wrap with an a over b squared sine of bx minus 1 over b cosine of bx. And now to find I, it's very easy, you just divide this thing over. So I is our original integral, it's e power of ax, and divide by 1 plus a squared or b squared. And this thing is unchanged, right again. And you may find it looks a bit different to the form we want, but it's okay, because you can realize if you just multiply this thing by b squared over b squared is multiplied by 1, doesn't change anything, the denominator will work out just fine. So it's equal to ax, and here is this thing multiplied by b squared, so the first one is b squared, and plus the b squared in the denominator cancels out, a squared, and if you multiply the top one, the b squared in, then you get this b squared also cancel, left with a sine of bx minus b squared divided by b is still b, gives you b cosine of bx. And then last step plus a c. And now you realize it's the same as the question. So it's what the question asks you to show. B squared plus a squared is obviously the same as a squared plus b squared. So that's the end of all the working outs. Okay, we have our third example here. This one is a hard one. And in looking this integral is the definite integral from 0 to infinity of natural log of x plus 1 divided by x plus 1 squared. And you can see it's again an integration by parts question, because natural log and the quadratic function here is very different functions. You need to use integration by parts in this case. And as I said, the R-late rule, you should choose Ln as the U, because L is before A, and besides you don't know what the integral of Ln is, so you can only choose it as U. So let's now just do it. U is Ln of x plus 1 and dv. So this thing divided by it just means multiply by it by the negative power. So it's x plus 1 to the power of a negative 2 dx. Now you can just differentiate. Du is 1 over x plus 1. So the derivative of Ln(x) is 1 over x, and if you have plus 1 here, it basically doesn't do anything. And integrate this thing, sorry, here should be 1 here. V is, if you remember the rules, you plus 1 to the power, so it's x plus 1, the power of negative 2 plus 1 is negative 1, and then you divide it by this thing, divide by negative 1. So this is your v. Or you can even simplify it. Divided by negative 1 is multiplied by negative 1, it is the same thing. And x plus 1 to the negative 1 power is just divided by x plus 1. And now you can just use your formula. So this will be equal to uv. U is this thing, Ln x plus 1, and the v is here, negative x plus 1. And now it doesn't change the upper and lower limits, you just need to substitute in. 0 to infinity. And minus v has a negative sign here also, so you just put this make a plus sign with another minus sign. V, so 1 x plus 1, and when du is another x plus 1 here, so in the denominator this thing will be squared, and dx. The bounds are the same, you just go from 0 to infinity. And now you need to get used to this integration by parts in the different integrals. You evaluate the first one and integrate the second one. So we'll do the evaluation first. So for the first case is negative ln of infinity, and infinity plus 1 is still infinity. I won't bother to write it in now. So in the bottom, infinity plus 1 is still infinity here, and minus, and there's another minus here, so just plus ln of 0 plus 1 is 1, so it's ln of 1, and here is 0 plus 1 is divided by 1, and we just leave it for now. We just do the second part, and this thing you may be familiar is the same as the dv in the first case. As you can see, is this one, x plus 1 to the power of negative 2. So it's the same thing as a v here. It just be negative 1 or x plus 1. It's the same thing here. I just pull out the negative here. You can just pull it out indefinite integrals and from 0 to infinity. And now we need to evaluate this thing. You may be wondering, how should I do this? Because ln of infinity is infinity, and divided by infinity, how should I do this? But you can see, because this infinity has a natural log in front of it, and it will be a very it's not small, but it grows very slow, and this one is a linear one, so the bottom is very large compared to top. Because if you look at the graphs here, ln of x plus 1 is basically this thing. It grows very slowly when x is very large, but x plus 1 is this thing. So in the end, when x approaches to infinity, it will be much larger than the natural log. So this thing is like a large number, but divided by an even larger number. So this thing will be 0 in the first case. Or you can just use a calculator and graph natural log of x plus 1 divided by x plus 1, and adjust your window to see the bar and behavior, and you see it's basically 0. And plus this thing, and ln of 1 is 0, as you know, plus 0. So the first part just 0. And minus, and for this thing, if you substitute infinity in, you get 1 over infinity plus 1, which is just 1 over infinity, and this 1 divided by a very, very large number is still 0, and minus, substitute 0 plus 1. So the first two zeros you don't need to care about, and this is also 0, and this is two negatives. I make a positive case, and it's 1 divided by 1, so which is 1. So the answer for this question is just 1.